Sketch the graph of the following on the same xy plane. Again, I'll make the table the value and plot the graph. So here I got my table value. So for this problem, when graphing, I will divide the scale as follows. This is -1, -2, 1, 2. And we'll go ahead and plot g to f the back to start with. So this is the graph of f of x. Next one, we do the graph of g of x. So note that the graph of g of x is smaller, it's narrower. And here is the graph of e to x. So here the graph of e to x is wider. Okay. So now that we can see that, we can make the conclusion. The graph of y equals c times f of x. So we multiply the function by a constant. If that constant is greater than 1, then stretch the graph of f of x vertically by a factor of c. So note that if you think of so let's take a look at the vertical value for c greater than 1. The vertical value is right here. Note that you multiply the vertical value by 2, right? So then the graph gets narrower, so you stretch in the graph. Whereas if the factor of the constant is between 0 and 1, then the graph shrinks by the vertical factor of c. So take a look at the vertical factor again. So here is 4, the vertical factor is now 2. You divide by 2 here. You shrink by 2, so it just gets wider. The next case, sketch the graph of the following on the same xy plane. So note that what's different here is we multiply in the variable. Okay. So again, I will create the table value, and I will have, the next thing I'll do is to plot the graph. Starting with f of x. So here's f of x. The next one is g of x. and the last one is eta max. So here we have the graph of f dot max, g dot max, and e dot max. To multiply a constant inside f dot x to the x value, if c is greater than 1, the graph shrinks horizontally by the factor of 1 over c. If c is between 0 and 1, stretch the graph y equal f of x horizontally by the factor of c over 1. Now, this is not very clear that you can see it. However, let's do a little bit of calculation you see differently. So let's compare the graph of f of x and g of x. And let's just write out the table of value separately. So let's take a look at f of x and g of x. So here's x value. -2, -1, 0, 1, 2. Then f of x is equal to -4, -1, 0, -1, -4. Let's take a look at g of x. Let's say if I want g of x have the same value as f of x. If I want g of x have the same value as f of x, -4, -1, 0, -1, -4, what would happen to the value of x? So I know that g of x is equal to 2 times x squared. So let's start with the first value. If I want g of x equal to -4, I can solve for the x value here. So x squared here equal to plus and minus 1. So, excuse me, x squared equal 1, so x equal plus or minus 1. So here's x have to equal 1. If I want g of x be equal to -1, what would happen? So replace g of x by -1. So x equal plus or minus 1/2. So now let's go ahead and compare the x value if the y value is the same. If I want the y value to be the same, looking at this, it is shrinking by a factor of 2. Take the x value on f of x divided by 2 to get the value of x on g of x. So this is this is what the relationship would look like, right? It does not explain on the y-axis, but it more explain on the x-axis. You can see the difference when you make the table the value. And so again, if c is greater than 1, then we shrink the graph horizontally by a factor of 1 over c, and if it's between 0 and 1, we stretch the graph by a factor of 1 over c. Let's take a look at the next problem. A function f of x is given, and to indicate transformation and apply to its graph, write an equation for the final transformation and sketch the graph. F of x equals x squared. We stretch vertically by a factor of 2. We shift down 2 units and shift 3 units to the right. So if we stretch vertically by a factor of 2, would mean we multiply vertically by a factor of 2. And we multiply a constant into the function. So here we start with f of x equals x squared. So then f of x, we multiply 2 into the x squared. Okay. And then what next? Shift out 2 units. So we minus 2. And shift 3 units to the right, so x minus 3. And you can sketch the graph from there. So let's sketch this graph. Let's start with the graph of f of x. So here we have the graph of f of x. Let's start sketching the transformation graph. Let's call that transformation graph g of x. Okay, we move down 2 units and to the right 3 units. So start with that part first. That you get your vertex. Take the vertex, move down 2 units and to the right 3 units. So that is your vertex. What next? You stretch by a factor of 2. So note that the distance from here to here, the distance from the first point to the x-axis is 1. So now we stretch by 2. So we take that 1 unit, we stretch to 2. And this is our new graph. So here's g of x. Next one, x to the third, shrink horizontally by a factor of 3. So when you shrink horizontally, that c value is greater than 1. So by factor of 3, so c here is equal to, so if you compare here, shrink the graph by a factor of 1 over c. Okay. So 1 over c equal to 3. This means c equal to 1/3. So then g of x start with 1/3, x to third, that's first part. Shift up 1 unit, so plus 1. Reflect across the x-axis. So reflect across the x-axis when we multiply -1 into the x value. So then this equation becomes and it's really just been -1/3 x to the third plus 1. We will graph this, start with the graph of f of x equal x to the third. So this is f of x, and let's graph g of x. it moves up 1 unit, shrink horizontally by a factor of 3, and reflect across the x-axis. So here what the graph would look like. Move up 3, move up 1, and reflect across the x-axis. So let's think about it. Take this portion of the graph, the highlighted portion, and we rotated it about the x-axis, then shrink it by a third. So this value right here, when x equal -1, y equal -1 will be shrink to when x equal -1. The difference between this distance here will be a third. Similarly, we got on this side. Okay. And we can sketch the graph. And this is the sketch of g of x.